All right, in this video, we want to take this picture and we want to write the rational function that would give us this picture. So we already know there's going to be division, right? So let's take the information that we've looked at the past several videos and let's identify the key pieces and let's put that into this expression. Now for me, I'm going to start with those vertical asymptotes because it looks to me like we have a vertical asymptote here when x equals -2, and then another one here when x equals +2. So if we kind of reverse those guys as factors in the denominator, that will be the factors x plus 2 and x minus 2. Okay. Now we see where we're crossing the x-axis, which is going to tell us where our numerator would have been 0. So we have the order pair here of -5, 0, so that would come from the factor of x plus 5. And then we have this order pair here, which is -1, 0, so that comes from the factor x plus 1. Everything seems to be okay, but I also want to make sure that we pay attention to the fact that we have this horizontal asymptote of y equals 1. And with that, that means that we have to have the same leading coefficient on the top and the bottom. So if I were to multiply these out, we would have x squared plus 6x plus 5 in the numerator and x squared minus 4 in the denominator. So if we were to go about and compare these pieces right here, we see they have the exact same degree. So we know there's a horizontal asymptote, and it would end up being the ratio of the lead coefficients, 1/1, which is what we have right here. And you know what? Let's see something a little bit extra. I see that I have a y-intercept right here. I don't know exactly what that is, but if I were trying to identify the y-intercept here, I'd plug in 0 and I would have 5 over -4, so -5/4, which, yeah, that looks reasonable. -1 1/4, I can totally believe that. But you know what? Let's just double check with the calculator. I'm saying that my numerator, now this is where I have to be careful. If you're sticking with just the factorizations, you need to have parentheses for the numerator, and then you do parentheses for the x plus 5, parentheses for x plus 1, close for the factor, close parentheses for the numerator, then divide by, big parentheses for the denominator, and in the denominator you have parentheses, x plus 2 times x minus 2. Oh, I missed that. Now let's graph this and see if what we have matches up with my picture. Okay, that looks good. Oh, look at that. That's a thing of beauty. Awesome blossom. All right, so cool. Let's look at the next one. For this next one, let's see how good we are at identifying the factors that make this up. We got a lot of things going on here. First of all, we see that we do have two vertical asymptotes. So we've got this guy right here, which is x equals -2, and here's this one that's x equals +1. So right away, we can say that in the denominator we have x plus 2 and x minus 1. There's another thing I need you to pay attention to, and it's this part right here for this x equals 1 vertical asymptote. You are going up to infinity on the left and going up to infinity on the right. So because they're both going up, it's a lot like the example that we had several videos ago about 1/x². So it creates that volcano shape, which means that that factor is going to be a square. That's how we get the asymptote to have the graph on the other side going in the same direction, either both going up or both going down. You see that around x equals -2, they're going in opposite directions. So that's why it's a linear factor just to the first power. All right, now let's use these x intercepts, basically zeros of this function, to give us the factors of the numerator. So I see that I'm crossing here with the origin, so that's going to be a factor of just x. I have this guy right here at -1, so that means x plus 1. And then over here at, to see, 0, 1, 2, 3. So that's the factor x plus 3. Now the last thing to verify here is this horizontal asymptote. Now, if you look at this very carefully, you'll see that it's not y equals 1, but it's y equals 1/2. Which means if you were to look at the leading coefficients, the leading terms would have the same degree, and the leading coefficients would have a ratio of 1 to 2. Now, if I were to expand out what I have, looking at how I have x to the first, x to the first, x to the first, that numerator there is going to be just x to the third, and some other stuff. I don't care about that. I care about the lead stuff. And then in the denominator, I have x, then I have x squared, which again is x to the third, and then plus the other stuff. But in order for me to have y equals 1/2, I need to have this in a ratio of 1 to 2. So the way that we fix that is just by putting a factor of 2 in the denominator like that. Okay, and let's just go over here and graph that and see if that is correct. So big parentheses, x times x plus 1, close it, times x plus 3, close the factor, close the numerator, divided by big parentheses for the denominator. That's 2 times x plus 2 times x minus 1 squared. Let's see how we do. Okay. I think we did it, guys. I think we did it. Yeah, so getting the factors shouldn't be that big of a deal for us, but you've got to watch out for the subtle things like the y equals 1/2 so that you get the right coefficients there to make sure that the horizontal asymptote does line up correctly. So you got to always check for that multiplicity. It's very easy to get caught up and you might forget the square. Now, if you had forgotten the square, just to give you an idea of what that would have looked like, and this is where we have fun with graphing calculators. How does that affect my graph? Yeah, that gives me something totally different. And if you look carefully, you can see that on the end behavior, we have something that looks like it'd be a slant asymptote, which would indicate that the degree of the numerator is just 1 higher than the degree of the denominator. Yeah, but that's not what we have in our picture. So use the calculator to check your work. And yeah, I think you're going to be right as rain.